Welcome to the video on function. In this video, we will talk about what is a function, how to represent it, and how to tell whether a relation is a function or not. First, what is a function? A function is a special type of relation in which each value of the independent variable is associated with an exactly one value of the dependent variable. That's confusing, right? So in short, in a function, one input produces one output. Let's just rewrite that. Output. It's like your keyboard. When you press the A key, it should only give the A on the screen. It shouldn't produce B or C randomly. So that's a function. You press A key, you see A on the screen. That's it. On the other hand, it's okay if two different inputs produces the same output. For example, instead of pressing A all the time, I can just drag, copy, and write more A's. I'm pressing different keys, but I'm still doing the same thing. So that is okay. Because two inputs, or two different inputs, produces the same output. It does not violate the rule of a function, where one input produces one output. Okay, so multiple inputs producing one output, that's okay. However, one input should not produce multiple outputs. So how do you represent functions? Well, a function is a relation. So we can use our usual ways such as equation, graph, a table of values, order pairs, or words. A special addition to these is a function notation. And it looks like this. We read it as y equals f of x, or y equals f at x. I like to say it the formal way, so I'm going to stick to that. In our example here, y represents the dependent variable, and the x represents the independent. In the meantime, the f is just the name of the function. As we add more functions, we can use something like g of x or h of x and so on, and it's fine. The fact that y equals f of x literally means that they're equal. So we can replace y with f of x. So what does that mean? So for example, we know how we use x, y as a ordered pair of a relation, right? And in this case, you see y here? Well, y is f of x. So we can just replace it like this, x and f of x. I can do this because y is f of x and they're actually equal to each other. We can just easily substitute them. The notation f of x means that f has an input of x. So x is our input, x is our independent variable. And because x is a variable, we can put any values. For example, we could say f of 2. It is simply putting 2 in the place of x. And let's use an example where f of x equals x plus 2. We could go like y equals f of x equals x plus 2. Then, if I do f of 2, then in the place of x, I just replace with 2. 2 plus 2 is 4. Okay, so f of 2 is 4. It means that when x is 2, f of x is 4, or aka y value is 4. Then we can make an order pair that looks like this, 2 and 4. Let's use another example. Let's say g of x is 2x minus 3. Then we can try to do something like g of negative 2. So then we can do 2 of negative 2 minus 3, which is negative 7. So again, we can put the order pair of negative 2 and negative 7. What if I put g of a? Well, we still do the same thing. The g of a means we're putting a in the spot of x. So we can just leave it as 2a minus 3, and that's it. What about g of 3a? Well, it sounds complicated, but we're still doing the same thing. We're putting 3a in the spot of x. So we can go 2 times 3a minus 3, which becomes 6a minus 3. We could go the other way as well. How do we solve f of x equals 5? Well, we just replace the left-hand side with the x plus 2, because f of x is x plus 2 equals 5, and then we solve it. So x is 3. On the other side, let's try g of x equals 5, and this would be 2x minus 3 equals 5, so then x is 4. Straightforward, right? Lastly, let's look at how we know if a relation is a function. Before we start, another recap. Functions, there are all relations. Let's say all functions are all relations. However, all relations, or not all relations, are all functions. Okay. One way to know is by graphing it first, and then doing the vertical line test. Vertical line test. We will learn how to graph a relation later, so let's just use the graph and see how it goes. Given the graph, let's say something like that. Okay, we can perform the vertical line test by moving a vertical line through the graph. You can use a pencil or finger or anything. We're looking for any moments during your movement, so let's I'm just going to scratch multiple vertical lines like that. And you're looking for any moments during your movement where the vertical line intersects with the relation twice. Have it ever met twice with the graph? No, so we can say that this is a function. It passed the test. Okay. Let's use an example, f of x. And f of x was x plus 2, so I think we can do something like 2, so like that. Then we do the vertical line test, and yes, it is a function. A g of x would be something like that. And then again we do the vertical line test, and yes, it passes all, so they're both functions. Let's try another example. So we have a relation something like that. Well, this relation fails a vertical line test because there are multiple moments where you see 2 or more intersections. So this fails a vertical line test, aka this is not a function. It is still a relation, but it's not a function. So a vertical line test fails even if there's only one point where there are 2 or more intersection points. Thinking about why vertical line test works with the definition of a function will be an interesting thought experiment. I hope you enjoyed this video and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.